Okay, last problem, problem number 10. It says, is the following reaction spontaneous at 298 Kelvin? And they give this reaction. Remember, when we're looking for whether a reaction is spontaneous, then we're looking at the Gibbs free energy, delta G. If it's at 298 Kelvin, we can use the same products minus reactants. It's the easiest way, and so they're helping us out here. We can use that, the Gibbs free energy, and instead of having to do it like the way we just did on number 8. Okay, so I'm just going to set it up the same way. I'm looking for delta G, and I'm going to take products minus reactants. So I've got 6 moles of this, and the last table I'm going to use is table 13.4. This gives you the standard Gibbs free energies of formation. Okay, so I'm going to look this molecule up in there, and I find that it is negative 175 kilojoules per mole. I'm going to subtract. Now I'm going to do the reactant side. I've got 2 moles of this C6H6. If I look on my chart, it is 125 kilojoules per mole. Okay? Plus, now if you look up here, I've got hydrogen in its elemental form and oxygen in its elemental form. Same as with Hess's law, elements in their elemental form are just 0. So I can put a 0 for this plus 0 and a 0 for this plus 0. So it's just this minus this, okay? So I go ahead and look. I get 1300, but I'm going to look back and see I need it to go to the ones place right here. This shows that it doesn't, so I'm actually going to have to change it and rewrite it this way using scientific notation so that we know that this is it actually was measured out to here. Okay, so oops, and this is negative, so delta G is equal to negative 1.30 00, goodness, that would be inaccurate, times 10 to the 10 to the 3 kilojoules. Okay, so they asked, is this following reaction spontaneous? If it is a negative answer, it is spontaneous at that temperature. If you got a positive answer, remember, when you have, for the Gibbs free like this, if you have a positive answer, you can't do it, so it's not spontaneous. But if it's a negative answer, you're good to go. Okay, so that's how you remember this last one. Okay, just 2 quick notes before I let you go. You're going to need to remember what Hess's law states. Okay, remember, it states that enthalpy is a state function, and it doesn't matter the path that you take to get to the final destination. Okay, it's independent of path. That's Hess's law. You're going to have to be able to know that. And the equation that results from it is really just products minus reactants, okay? But we know it's the summation of that, okay? So I would say the summation of delta H of formation of products minus the summation of the delta H of formation of reactants. So that's the really fancy way, okay? But you're really saying that it's the sum of the products minus the sum of the reactants from that list of standard formations. And the other last thing, remember when we're using bond energies, if I use bond energies versus Hess's law, and they ask me, why are you going to get a different answer between the two? Because really they're talking about the same thing. Remember, bond energies don't take into account the phases, okay? The gas versus the liquid. So Hess's law does. So it should make sense to you that if you're being more precise with your having phases on your reaction, that your answer should also be more accurate, okay? So that's why you're going to get a slightly different answer between the two, okay? All right, so you're going to take your test for Module 13. I hope you do great. If you're going to continue on, so if you're going to do the extended schedule and do Modules 14, 15, and 16, you're going to go ahead and read. You're just going to continue on like we normally do. You're going to read through it, do the on your owns, and then we'll be coming back and doing the review problems, the review questions, and the practice problems. If you're not and you're on the shortened schedule, you are, after you take this test, you are done for the year and you finished chemistry. So awesome job. I'm really proud of you guys. So all right, so if you're going to continue, you'll see me in the next videos. All right, bye.